To build a piano that endures for decades, the process must begin with something unmistakable: fullers. Each timber batch is individually identified, allowing full traceability: tree age, harvest zone, and
Full-length scanning identifies critical defects, major cracks, oversized knots, and weakened core zone.
when the material weighs as much as a building, every movement must lock perfectly on center.
High-force clamping prevents the timber from breathing during cutting. Stability is not optional here. It is a survival principle of precision machining.
Now comes the moment most people wait for. Cutting begins. This is where a colossal sequoia trunk.
The cut follows the longitudinal grain. The straighter the grain, the less the soundboard shell will warp as temperature and humidity change.
Billets are separated strictly along the grain path, not by convenience. Piano construction offers no forgiveness for misaligned wood orientation.
Thickness, flatness, and parallelism. Every parameter is locked into data from the very first minute.
This is rim-grade timber, where sequoia performs at its best, carrying structural load and protecting the instrument's form.
Natural air drying takes 1 to 2 years, slow by design, but essential for letting the wood stabilize its character before entering the kiln.
Moisture content is the heartbeat of an instrument. Miss it by even a small margin, and cracks, warping, and failure follow.
After natural air drying, the wood enters the kiln, drawn down to 6 to 8% moisture. This is the threshold demanded by musical instruments.
This stage determines most of the durability. Not 10%, but nearly all of it.
From this point, the wood is locked into a stable state, ready to move forward into shaping the instrument's shell.
A piano rim is not carved from a single solid block. It is a laminated structure, engineered to be strong, light, and stable. Lamination begins with exact thickness control. Miss even a fraction, and the layers will crack when bent.
Adhesive is applied evenly, and grain directions are alternated by design, building resistance against cracking as temperatures change.
Steam softens the wood to the exact point required, pliable enough to bend, yet without breaking the internal grain structure. There is only a narrow time window. Delay the transfer to the mold, and the wood stiffens immediately. This is the moment the piano rim is born, bent precisely into the form that defines the instrument. High pressure forces each layer into full contact. Any gap left now becomes a structural weakness later.
An American-style factory runs like a formation, and each mold here represents a future instrument taking shape.
Adhesive must cure on the correct cycle. Too fast and it turns brittle. Too slow and it remains weak.
The objective is strength without excess weight, and absolutely no cracking.
Bending alone is not enough. The rim must be machined to exact geometry before the remaining components can be fitted.
The connection groove, where torsional loads and vibration will ultimately pass.
A piano is precision mechanics. Even minor deviations can turn into noise, misalignment, and long-term instability. Sequoia continues in its strongest role, providing protection, load-bearing strength, and long-term dimensional stability.
The wood is beautiful, but it must operate under strict engineering discipline.
The backboard does not create the primary sound, but it defines the rigidity of the entire body.
Every groove and every bore is a load path. This is where 18 to 20 tons of string tension will ultimately be transferred.
Reinforcement must land exactly where designed, so the rim does not fatigue over time.
Vibration testing confirms the rim has no loose points. Looseness is the enemy.
Here, Sequoia performs exactly as intended, carrying load and providing protection without competing for the sound itself.
Now comes the most critical part of a piano, the soundboard. And it does not use Sequoia.
If Sequoia were used here, the sound would turn dull and lack projection. Spruce is the true heart of the instrument's voice.
Soundboard joints must seal like a single skin,
no voids, no offsets.
This is not uniform planing. Each zone carries its own thickness, tuned to control vibration and projection.
Precision here is absolute. Even a slight deviation is enough to change the voice of the instrument.
Resonance ribs form the soundboard's skeleton, guiding vibration so it moves correctly, without collapse. Too little adhesive leaves gaps. Too much adds weight and chokes the sound. What matters here is balance.
Only uniform pressure preserves flatness, while still allowing the soundboard to vibrate freely.
The soundboard must rest in a controlled environment, so its voice does not shift with the seasons.
One tap is enough to tell this board is ready to sing.
Piano strings carry enormous tension, so the cast iron plate must shoulder roughly 18 to 20 tons.
Cleaning, corrosion protection, and surface preparation, so the plate can live alongside the wooden body for decades.
This is the moment the metal backbone meets the wooden body. Every contact point must land exactly where it belongs.
Correct torque, correct sequence, so the load distributes evenly and the wooden body is not twisted.
Once locked, it is locked. There is no room for almost right.
The pin block must be a different hardwood. Sequoia is not used for tuning pins. This is where tension is held.
Pin tightness determines tuning stability. Any looseness and pitch will slip.
The pin block must be installed on true axis, so strings run straight and forces remain balanced.
From this point on, the instrument begins to carry tension, a necessary tension that gives music its power.
The keyboard and action are precision mechanics, and they also do not use Sequoia.
Keys must remain stable, stiff, and resistant to deformation. Maple fulfills that role precisely.
Hammers, levers, and springs work together, creating the sense of weight and response beneath the player's hands.
A great piano is not only about sound, it must return the correct feel to every finger.
Adjustments are made in fractions, so the hammer strikes correctly, rebounds cleanly, and stops exactly where it should.
Now comes final assembly. Every part must mesh together like a living machine. Sequoia is beautiful, but its surface must be filled and sealed, so moisture cannot return. Sanding is not only about shine, it ensures even paint adhesion and long-term wood stability.
Finish is armor. Correct layers and proper curing time are what allow the body to survive real-world environments.
Gloss meets standard without excessive build. Too much thickness would upset the body's balance.
Polishing turns wood into something people want to touch, while strict engineering discipline must remain intact.
Gloss builds layer by layer. No heat, no burn-through, and no rushing the process.
The lid mechanism must be smooth and secure. Even a slight misalignment can distract the player.
A piano is not tuned once and finished. It must learn how to carry tension. Increment by increment, building tension without shocking the wood or the frame.
Tuning is repeated many times because stability must be proven over real time, not momentary feel.
Key weight is balanced, so every note feels identical. No heavy keys, no light ones.
Regulating the action is shaping the piano's character, fast, clear, and fully under control.
This is industrial strength at its peak, precise, durable, and uncompromising toward error.